Alright, so a maybe data type works like this. So first you want to find an @ sign in the string, let's say. And you want to find a dot in the string. And you want to check the length of the string. Instead of doing if statements and like if m1 then blah 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 etc. for error reporting, we are going to do something like this. So if any of m1, m2, m3, and in that case we're going to return the maybe of the string. So a maybe is like a box. It either contains nothing or it contains a value. So I have prepared just a tiny bit. So I have a generic Makefile, just compiling this stuff. I have a couple of integer data type, as I usually do. And I have a couple of aliases, a couple of macros for converting between those data types. By the way, many of my viewers are having trouble knowing how to start, how to begin a programming project. Are you one of them? Please check out this episode in the video description, where I teach my very simple method in 3 steps how to start any programming project. So, how do we do this? First, we need to define the actual data type. So, this is going to be a struct, so let's start there. And it's going to have 2 things. It's going to have a type. So, and this is going to be a bool. Since we only have 2 types, we have nothing and we have just. And we need booleans. So let's include stdbool.h. And let's also define these 2 types. So let's define nothing as false for this type. And just is going to be true. And later on, if we have time, I'm going to show you a different type which works similarly but a little bit more advanced. And then we're going to have maybe more than 2 types. And then we will have some int 8 or something here. But for now, we will just do this because we only need 1 bit. And then we are going to have a void with a value. So we can put a pointer to anything inside of here. And we're going to type def this. So struct as maybe. And we're going to call this maybe like so. Alright, so what do we need here? We need a constructor function which creates a maybe. So let's say it's going to define a maybe pointer. And this is going to be called, let's see how we're going to do this. We can call this maybe with small letters. And what is it going to take? It's going to take let's see. We need 2 things. First we need to decide. Let's do it like this. Let's say we have a void star here. And if that void is 0, but yeah, let's do it like this. Maybe we can improve it later. So let's start in this end. I also want to have macros for memory allocation. So I want to have an alloc of x, and that is going to return malloc of x in this case. Maybe we want to have a different memory allocator later. That's why I do it like this. And I'm going to have a destroy, which is going to call free, which means we need unstd and stdlib.h. I also want to have a function which zeroes out a data type. Let's call it 0. So it's going to be a void 0. It's going to take an int 8 star and an int 16 for the size. So let's code these two functions. Let's start with the 0 function. So we have some some string or whatever here, and we have a size. So we need some counter, and we need a pointer. So p is equal to the string. N is equal to the size. As long as we have an n, we will iterate, and at each iteration we're going to increase p and decrease n. And we're just going to set current characters to 0, like so. Alright, so how do we create one of these data types? Actually, I think I'm gonna yeah, I'm gonna do it like this. I'm gonna take another parameter. So let's say we have a bool here. So this bool is going to indicate if we have a value or not. That way we can return 0, but still have it as a value, so to speak. So let's see. We have maybe. We have bool has val, let's say. Or maybe we can do it. Let's do it like this. And then we have a void with the actual value. So let's start by allocating space for this thing. So let's say we have an int 16 size, which is going to be the size of a struct s, maybe. And let's allocate. So p is equal to a maybe of alloc size. So let's let's cast this x to an int 16. And I want to use, what's it called? Assert. So let's include assert.h and rnumber.h, and we need to define GNU source. Difficult to spell this, it seems. So let's assert that we have a p and then zero out p with size, like so. Alright, so now we have two different scenarios. So if we don't have a value, in that case we're gonna set type equal to false, and we're gonna set val equal to void 0. Otherwise type is true and val is equal to val, and then we return p, like so. Let's also create a show function so we can easily debug this thing. So void show maybe maybe and this is going to be a simple function. So show maybe, we have a maybe m, let's say. So if we don't have an m at all, we just return. And if we have an m but it's empty, maybe we can do if empty m. Let's take in a string as well, with the name of this data, with this variable. So we have an int 8 star, because then we can do something like this. Alright, so if we have an empty, we will print nothing. Otherwise, we will print just the value. And how are we going to present this value? Because it can be different data types. Let's print the address. So something like this. We make an integer out of val. Like so. And then I'm going to create a simple generic macro, which is just going to be called show. Show of x. And if we have a maybe star, we're going to call show maybe. And we're going to provide the string of the variable name and the actual variable. Something like this. All right, so let's try this out. So let's say we have an, I don't know, an int32 val and a maybe m. We set we set val equal to 500, and we set m equal to maybe. We set this to true because it's going to contain a value. We provide val, and then we show m, and then destroy m, and return. All right, let's see if this compiles. We forgot the empty. So the empty macro is going to check if it contains a nothing or not. So we will have an empty of x, and it's going to return. So let's see here. So if we don't have an x, don't have an X type. So if we don't have an X at all, it's going to return true. And if we have a nothing, it's going to return true. Something like this. Makes pointer from integer, that is true. Need to cast this to a void. Okay, compiled. Segfault. Huh. I did not see that one coming. Interesting. I wonder if it's the show or the other one that is crashing. It is the show. Okay, so... Oh, I forgot to add the argument here. Rookie move. Okay, there we go. So in this case, we have an m which is equal to a just of this value, which is 500 in decimal. And let's say we don't provide a value, so we can just change this to false. And then it's equal to nothing. And we can even set this right here to true, and we can provide a 0. So a valid 0 value which is not empty, so to speak. And this is one of the advantages with this. We can return a 0, but it doesn't necessarily need to be an error because of that, so to speak. All right, so now we have a maybe data type. But we need to have some more functionality before it's really useful. So let's code something something which we can use this for. Let's say we have we need to validate an email address, let's say. And we're not going to make it really advanced by checking that the top level domain is okay and blah, 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 blah. I'm just going to do a couple of small checks. So let's create we're going to return a maybe, and let's say let's call it validate, and it takes an int8 string with the email address. Let's clean this out and let's create this function. So maybe validate, and we have an int8 email. So let's say we have a couple of checks here. So let's create 3 maybes. Let the first be equal to validate so let's see here. Mm. So what do we want to check? Let's check that there is an @ sign inside of this. So has @ and we provide the email. And let's say we have a dot. And let's check the length. So it's not longer than something and not shorter than something. And let's write these functions real quick. So we're gonna have a has @ we're gonna have an has dot, and we're gonna have check length. And in order to write these functions, we need 2 things. We need a function which checks the length of a string, and we need a function which finds a character inside of a string. So, so let's say we have a bool in string, or find char, let's say. And we need to have a, let's see, what we're going to call this, string len of int 8 star. So let's write these 2 functions first. Let's start with a length function. So string len, and we have an int 8 string. We need an int 16 which counts, and we need a pointer. Set n to 0, p to string. We go on as long as we still have a character. At each iteration we increase p and we increase n. And then we just return n. All right. And let's do one for the find char. So bool find char int 8 string. And this is going to be pretty similar. We're going to have a bool for the return value. Let's call it found. We need a pointer. So we set found is equal to false. Set p to string. We iterate as long as we still have a character. At each iteration, we're going to increase p. And then we're going to check, is the current character equal to, well, we need to provide one, doesn't we? Don't we? So let's do it like this. So we need an int 8c as well. So if this is equal to c, then we want to set found to true, and we want to break, and then by the end we return found. Okay, so now I have these two. So let's start with this has at, which would be very simple, I think. Has at, and we have some string. Maybe we should have some kind of checks as well. So let's make sure that we have a string. Same here. Now we don't need to check for that here. All we need to do is we just we just need a return statement. So if find char string and an at sign. So if we find that thing, in that case, we want to return maybe true. This value doesn't matter in this case. That's right, we don't need to provide this value, so we can write this a little bit nicer. So we will return a maybe in either case, but this right here, this first argument, here we do the check. So if find char string and at, and this is going to return a bool. So we can do it like this actually. and then the second argument doesn't matter. And we can do basically the same for has dot. Change this to a dot. And what about the third function? Check length. So here we can return a maybe. And we will do a check, so let's do this. Int 16 len. Len is equal to string len of string. Then we return, and if the length is less than 3, or if length is more than 64, let's say. Or let's make it 16 so it's easier for us to test it. So these are just arbitrary values, just so we have something to validate with. So if both of these are true, let's see here. If both of these, if any of these are true, then we want it to return false. So let's reverse this whole thing. And then as the second argument, we don't care. Alright, so something like this. So now we have tried to validate this email address, and we have 3 responses, 3 return values. And now I want to do something like this. So let's say if all let's see here. Yes, if all of M1, M2, M3 in that case, I want to return, I will set ret equal to a maybe true, and provide the email, let's say, and the response. Otherwise, ret is going to be a maybe, which is false with an empty value. So I think we are starting to understand the beauty of this thing. So we can just run our checks. We check if all of them passed, and then we return a maybe which has the email address as a value. Otherwise, we return a nothing. But how do we code this all function? That's a little bit tricky actually, but let's try. Because if we were to define it statically with 3 arguments, so it always has 3 arguments, and if you have less than 3 arguments, you can pass zeros here or something. But what if you have more than that? So the best way would be to make this variadic, so it takes any number of arguments. But how do we know where it stops, so to speak? So we need to add something like a 0 at the end, just to stop it, so to speak. So let's define all as an alias, as a macro. So we have all of args and we want to call, let's say, underscore all, which is the function. And we provide the args, and we provide a 0 at the end. So we need to cast that 0 as a maybe. Something like this. And how will the signature for the all look? Well, it's going to return, let's see, what do we want it to return? I guess we just wanted to return a bool. So bool underscore all dot dot dot. Let's do it like this. So we pass a maybe and then dot 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 to make it a little bit easier for us, which means we need to do the same here. So we have an x and we have some args. We want to pass x and then the args. Right. So let's see if we are able to code this function. So it's going to return a bool. It's going to be called all. We have a maybe arg1, and we have some additional arguments. So we need at least 2 arguments total. So let's see here. So let's say we have an int 8p. We need a maybe m. let's do a for loop where we set p equal to arg1, and we continue as long as we have a p, and then we want to go to the next memory position. So here it depends a little bit about your platform. Since I'm on a 32-bit machine, we're gonna make 4-byte jumps. No, we can't check it like this. We need to check we need to check that we have an M. That's what. So maybe we don't need this initializer. We can do it here instead. So let's say P is equal to arg. And we also need a pointer to a pointer. So let's call this PP. Because we need to take the memory address inside of P. So we need to cast this to a maybe double star P, and then we can set M equal to PP dereferenced. And this we need to do at each iteration as well. So the next P will be, let's see here, what direction are we going? It should be minus equal to 4. Since each argument on the stack is 32 bits on my machine, if you use a 64-bit environment, you can do 8 here instead. And then we will set PP equal to the maybe double star of P, and M. We can't do references here. So we need to check if this PP is 0. Then return false. Yeah. So let's skip this step here. So what are we going to do at each iteration? Well, we're going to set m to this argument. And if we have an m, we're going to check if it's a nothing. And in that case, we return false. Otherwise, we just continue going through them all. Don't need to do this here. But we still need to check the m here. Let's keep it. I think this is right. And if we go all the way down here, we should return true, because if we haven't aborted earlier, everything should be okay. But this function became a little bit more complicated than I had hoped, but let's see if it all works out. So let's take in the arguments here. Okay, so let's create a maybe m, and m is equal to validate, and we provide our email address. Then we show m, We need to clear this out as well. We destroy m down here. Return 0. Okay, we probably need to troubleshoot this a little bit, I think. Oh yeah. Are we stepping the wrong direction? Yeah, we were. Okay, so let's clean this up. Alright, so if we run this with the correct mail address, so then we get a just and some address which points to the string. If we miss the dot, we get a nothing. If we miss this, get a nothing. If it's too tiny, we get a nothing. But if all are okay, we get the value. And this we can just use. This is just the string of the thing. But we can use this all for any number of arguments, at least 2 or more. And we could create a reverse function which is called none, which will make sure that none of these are containing a value. But that's homework for you. We have achieved quite a lot. So now if we want to use these data types, it's very easy because all the functionality we need is already done. So the only thing the user needs to use here is the constructor function, which creates the thing, which is this maybe function here. And they might need, well, the all as well. So I really hope you liked this episode. I don't think there is something similar online, in C language anyway. So please don't forget to give a thumbs up if you learned something today. And thanks for watching. Thanks for tonight.